Hello everyone, this is program number 5 and in this video we will discuss how to implement merge sort using Java programming. Then as you all know that the sorting is a technique used to rearrange all the array elements either into ascending order or descending order as per the requirement. Then also you know that merge sort is one of the important algorithm or a technique that must be best solved using divide and conquer technique. That is nothing but your original array you have to divide into sub arrays, and finally you have to apply sorting on a sub arrays when no more further division is possible. This is the simple technique we are using to implement the merge sort is divide and conquer technique. Just go on dividing the original array into sub arrays, and when no more division is possible, start merging the sub arrays or start merging elements from sub arrays to get the original sorted array. Let us I will explain this program by line, or we can discuss this program as a merge sort. Then starts first import the class as the java.util.random class to generate all the random numbers and store the random numbers into your array. The next you have to import the class as a scanner to define or to create interface for the input device. Then public class merge sort is the class name. Then integer a is the array variable you have to declare. The next you have to create one local variable as integer num. Then the next you have to create object for a random class as rm with operator as with new operator new random. Then static scanner in is equal to new scanner system.in, create one interface for the input device. Then by using constructor as a merge sort, using constructor function as a merge sort, you have to read the n value, that is the array size, or how many elements you want to store into a array as a n. Then you have to assign this n value to this local variable as num is equal to n, and you have to initialize the array variable, or you have to assign the size of array variable a with the num value. The next is you have to make call to this data input function to read all the actual array elements. The two techniques we are using here, it can possible to read the numbers array elements randomly, or it can possible to read it from manually. We can discuss this both the techniques to read the numbers manually or to read the numbers randomly at the time of execution. Then just this is an data input function to read all the array elements. Then the next two important functions we are implementing in this merge sort is, one is called as the merge function and one is called as the merge sort function. That is merge sort function. Then merge sort function is just an recursively you are calling make to this same function. Then let's start our discussion with the main program, that is public static void main string args. Integer n is the local variable as the n defines number of elements into the array. Then system.out.println, enter the value of n. For better complexity you can provide the n value greater than 500 greater than 5000. Then n is equal to in dot next integer. Then you have to create object for the merge sort class as merge sort m is equal to new merge sort, and provide this n value as the input for the constructor function. The next call to this input function using object as m dot data input to read all the array elements either manually or automatically generated by using the random numbers. Then you have to display the merge sort. You have to display all the elements once before sorting by using function m dot display function. Then again you have to use one variable called as the start time variable, and that will simply mention, or that will simply record the time at which you started executing merge sort by using the function as system.nanotime. That will simply records the time at which you begins executing the merge sort function. Then next you have to make call to this merge sort function by providing lowest value and the highest index value for the given array as 0 is the lowest index value for the array, and the n minus 1, that is size minus 1, is the highest index value for that array. By using lowest and highest index value you have to make call to this merge sort function. Then again once this execution is completed, the sorting is completed successfully, you have to display all the array elements once again after the merge sort by using m dot display function, and again you have to record the stop time at the moment you are successfully completed the sorting function by using again system.nanotime function, and you have to display once again all the sorted array using m.display function. Then you want to know what is the elapsed time, how much time this algorithm takes to complete its execution. You have to simply subtract the start time from stop time divided by math.power of 10 raised to 6, that is it will simply convert nanoseconds into milliseconds by using the built-in function as math.power function with 10 raised to 6 as the input. And finally you have to display the time complexity, and you have to display with the elapsed time. Then let us see how it will work. We start executing this program with a merge sort function. Then you have to first make call to this merge sort function. As I already explained that the two major operations we are using in this merge sort is just go on dividing your original array into a sub array until and unless no more further division is possible. The same simple divide technique we are applying to solve your merge sort. Then let us see here what happens for wired merge sort, integer low value and integer high value. That will simply indicates the lowest index value for the array and highest index value for your original array. Then originally lowest index value is 0 and highest index value is n minus 1, where n is the array size. Then integer mid value, integer mid value. Then if low value is less than high, this condition is true, you have to calculate the mid value as mid is equal to low plus high divided by 2. And once again you have to make call to this function, same the msort function recursively by using msort with the new index value as the low value as it is and high value as a mid. Once again you have to make call to this function as msort with the low value as mid plus 1 and high value as high. This is nothing but you are dividing your original array into sub array. And the once no more division is possible, you have to make call to this merge function that will merge all the elements from sub arrays, all the sorted elements from the sub arrays to get the sorted list for the original array. That is merge sort with low value, mid value and high value. These are the inputs for merge element, or this is a call for merge function. Let us see how merge function will work. Then here is a definition for a merge function. Then let us see how actually the merge function works with the inputs as low, mid and high. Then here you have to, for this merge function again you have to create the local variables as I, j, h and k. These are all used for implementing looping statements in your application. Then you have to create the one more empty array variable as a b, as integer b is array variable with new integer and a dot length. It has the same length as that of your original array a. Then initialize you have to I value and h value is equal to low, and also you have to initialize j value is equal to mid plus 1. Then you have to check for this condition while I is less than or equal to mid and j is less than or equal to high, and you have to check if a of I is less than or equal to a of j. Then you have to simply copy the element from a of I plus plus to the b of h plus plus. You have to simply copy all the elements. If the element is smaller than the next element in the array A, then you have to simply copy that element to this resultant array B. Else you have to copy a of b is equal to b h plus plus. And if I is greater than mid, then you have to calculate for k is equal to j, k is less than or equal to I, k plus plus, and b h plus plus is equal to a of k. Else for k is equal to I, k is less than or equal to mid, k plus plus, b of h plus plus is equal to a of k. And for k is equal to low, k is less than or equal to high, k plus plus, a of k is equal to b of k. By using this application, you have to merge all the elements from the sub arrays to get the sorted list into your original array. Then next we can execute this program with some sample inputs. Just execute this program with sample inputs and enter the size of the array as suppose 6. Then enter the elements as suppose 55, 22, 66, 11, 44 and suppose 33. Then these are the elements before sorting: 55, 22, 66, 11, 44, 33, and these are the sorted elements after 11, 22, 33, 44, 55 and 66, and this is the time complexity. This will take approximately 0.06 milliseconds to complete its execution. Then now let us see this execution once again by using automatic number generators. Just put the command for this program, and you have to read the array elements randomly or automatically generated using the random function. Save this and you have to execute it once again, and here you have to enter the array size as suppose 100. Then here it will generate all the random numbers between 1 to 100 automatically by using the random number generator. All the random numbers generated are stored into an array. Then to that array you have to apply the merge sort, and you will get, after applying merge sort, you will get the sorted list as shown in this example or as shown in this output. After the sort you will get all the sorted array or all the sorted array elements, and this is the time complexity as 0.17832. This much time it will take to complete its execution.